So in this video, we're starting off chapter 1 and we're doing sections 4 and 5. So in sections 4 and 5, we're going to be multiplying and dividing real numbers, and then we're also going to be looking at prime factorizations and least common multiples. So the first section, chapter 1.4, we're doing multiplication and division of real numbers. So here are your rules. The shortcut, instead of memorizing this whole chart at the top half of the screen, if you just want to remember the acronym SPAN, S stands for same, they're positive, if they're opposite, they're negative. So that's a shortcut to remember that whole top part. Also, there's this thing called the Ninja Man, and whichever two signs that you have, you cover those two up. So if you had a negative and a positive, you would cover up the negative and positive, and it would be negative. If you have a negative and a negative, it would be positive. If you have positive and a negative, it would be negative. So those are just two other memory tools. Also, you'll see over in the left-hand side of your screen, if you have a 0 on the bottom, if you have 0 on the bottom, you can't have that. That's the undefined. If you're dividing by 0 on top, that's okay. That one is 0. So there are just a few rules to make sure you commit to memory. So here are our first examples. You're going to multiply the numbers and keep whatever the sign is. So in the first one, I have 4 times negative 3. So because it's a positive number multiplied by a negative number, my answer is going to be negative, and then 4 times 3 gives me 12. So my final answer will be negative 12. In example 2, you have negative 3 times negative 2. So because I have two negative signs, negative 3, negative 2, I'm going to have a positive 6. And then in example 3, you'll have negative 30 divided by 5. So I have a negative divided by a positive, which is going to give me negative, and then 30 divided by 5 will give me 6. So my answer will be negative 6. In the last one, you'll have 16 divided by 0. So if you remember in that last diagram, we saw that 0 on the bottom was a problem. So 16 divided by 0, that is going to be undefined. This next example deals with prime factorization. So with prime factorization, you're going to take a composite number or a number that has divisors. You're going to break it all the way down into the prime numbers. It doesn't matter which two numbers you start with, just as long as they do actually multiply to the number. So for 90, I could start with 9 and 10. You could start with 3 and 30, and you'd still get the same prime factor, just as long as the numbers multiply to the number in the question. Well, 9 isn't prime, so I'm going to break that up again to 3 and 3. Now that's finished, because 3, the only thing that multiplies to 3 is 1 and 3. I'm going to do the same thing with 10, so 5 and 2. And then I want to write it in the prime factorization form. So I would say 90 equals 3 times 3, I can write as 3 squared times 5 times 2. So I just carried everything down. Now convention says to write it in chronological order. So I would want to write this as 2 times 3 squared times 5. And if you multiply those in your calculator, you would indeed get out 90. So that's a good check. If you multiply this part, you should get out this part. If you don't, then something in your factor tree went wrong. So my second example is 294. We have 6 times 49. Well, 6 is not prime, so I want to break it down again. So I have 3 and 2, and then 49 is 7 and 7. So everything is prime. So I have 294 equals, I want to write the smaller number first, 2 times 3 times 7 times 7 is the same thing as 7 squared. So I have 2 times 3 times 7 squared. If you multiply that out, you would get 294. So the last two examples deal with the LCM, or the least common multiple. So I want to find the least common multiple of 4x squared, x squared, y, and 6x squared. So the first thing you'll see is to find the prime factors, or to break everything up. Well, 4, the prime factors of 4 are 2 and 2, which is 2 squared. So I have 4x is the same thing as 2 squared times x. Notice I'm putting them in chronological order and the letters putting in alphabetical order. So the next one, x squared y, that doesn't have any numbers, so there's nothing to break up. X squared y. And then the last one, 6x squared. So I'm going to break up 6. My prime factor tree of 6 is just 3 and 2. So I'll have 2 times 3 times x squared. Okay, so there's my prime factor tree, or my prime factors. Step 2 says that you want to find the most number of times each factor is used. So here I have 2 squared, so that's going to come down. I have an x squared, so that's going to come down. And then these other things are just going to fall down below. A 3 and a y. So my prime factor is going to be when I multiply these all together. So 2 squared is 4. 4 times 3 gives me 12. X squared y. So that would be your least common multiple.